Okay, last during the last term, we started on chapter 11. So in chapter 11, first we talked about physical change versus chemical change. So the main differences is for physical change there will be no new substances formed, while chemical change there will be new substances formed. And physical change are usually reversible, and you use your separating techniques learned in Sec 1 to obtain the constituents back. And then for chemical changes, they are usually not easily reversible. So examples of physical change, you have your phase changes, so melting, boiling, sublimation, and freezing. Okay, and then dissolving is also a physical change. So chemical reactions wise, we learn two ways to classify chemical reactions. One is when two reactants combine to give one or more products. For example, we have ethanol plus oxygen giving carbon dioxide plus water. So this is a word equation, and for Sec 2, you'll be required to write word equations. So that will be what you'll be doing after this mind map. Okay, then chemical equations you do not need to know now, okay, but be um it will be very popular next year in chemistry. So that's why we are showing you this earlier on. Okay, so the second way to classify chemical reactions is when one reactant, okay, decomposes to give two or more products. For example, calcium carbonate under heat it will decompose to give calcium oxide and carbon dioxide. And also we learned about this way to represent the compounds and elements. So carbon react with oxygen, okay, they rearrange and give you carbon dioxide. So we can see from this equation that atoms are conserved. So as a result, mass is conserved during a chemical reaction. So nothing goes missing. Okay, then moving on. Afterwards, we talked about 11.2. We learned a few types of chemical reactions. Okay, so we have combustion, thermal decomposition, and oxidation. And these two definitions are especially important. Okay, this is not a proper definition, but what happens is at the Sec 2 level, you are not really required to know the definition, but you need to know that oxidation um, occurs when a substance gain oxygen. And then for combustion, is when a substance is heated in presence of oxygen, and it will then form one or more new substances. And then the thermal decomposition is a process in which a substance breaks down into two or more simpler substances upon heating. So the key point here is heating. Okay, that's why thermal decomposition. Okay, so you have a few examples that we copied down previously. Can you all add in this part? Okay, this is cellular respiration. So it's another example of oxidation, and this is what happens when um food molecules such as so food molecules such as glucose will break down in the presence of oxygen, and this will then give off energy to the cells so that the cells can survive and reproduce. Okay, and last part we talked about neutralization, which is a type of acid reactions. So we differentiate an acid from a alkali or base. So something that I've not mentioned is, so base are any metal oxide or hydroxide. So if you look at your periodic table, hopefully you remember how to separate the metals and non-metals. but this is how I separate them. So from group 13 onwards, I draw one big line, and then I have my staircase. So it is very clear cut that this is metal and this will be non-metal. Okay, common problems is when students draw it like this. Okay, then you realize then there's no clear, then they are missing non-metal elements lah. Yeah. Okay, so uh this is how I remember. There is this line here that separates the periodic table very clearly. Okay, so any metal, so lithium hydroxide, beryllium hydroxide, sodium oxide, magnesium hydroxide, they are a base. And then alkali are bases that can dissolve in water. Okay, so there are some physical properties that you just need to memorize. Okay, so acids are generally sour taste and alkali are bitter taste. So when you taste vinegar, actually what you are tasting is, from yesterday's experiment, we know that vinegar is actually ethanoic acid, so a kind of acid. Okay, then we have three examples. This one you need to know as well. These are important. Okay, you don't need to know the chemical formula now, but you need to know these three acids exist, as they will be tested in the word equations. Okay, then acid is pH 0 to 6, and then if it's 7, then it is neutral. Okay, then alkali and bases will be pH 8 to 14. So from yesterday's experiment, we also know that litmus paper acid will end up being red. Alkali will have the end up being blue. Okay, then for universal indicator, this one I've mentioned a lot of times. Roy gave birth in Vietnam. Red, orange, yellow, green, blue, indigo, violet. So do not write pink or anything, or magenta or cyan or anything else. Okay, so there are three reactions you need to memorize for this part of the chapter. They are all equally important. So acid plus alkali give you salt plus water is the neutralization reaction we are talking about. So these are not neutralization reactions. They are simply reactions that can happen to an acid. Okay. And for acid metal, it produces hydrogen, which we have a lot of fun playing in the lab with. Okay. So when they ask you how do you test for hydrogen, what is the positive test for hydrogen? It extinguishes a lighted spin with a pop sound. And the positive test for carbon dioxide is white precipitate formed in lime water. Okay, so after the reactions, what happened is you need to know. Okay, so before that, so litmus paper and universal indicators are actually simply they are indicators. So just like the name suggests, it indicates to us whether the substance is acidic or alkaline. Okay, so here we have a what do you call this, summary of how the litmus paper will turn out. So I forgot this part. So a neutral solution will not have effect on red and blue, so it will not change color. Okay, and then we have some other indicators which you will use, which some of them you'll use in upper sec. Okay, so they have different colors. So basically, if I have to test, okay, so I might ask you, this substance is at pH level of 2. So if I add methyl orange, what color will I get? And then if a substance is pH 9 and I add bromothymol blue, what color will this uh, substance become? Okay, and then there are also natural pH indicators such as the red cabbage. So this is your 11.2.3 C, which we will not do. Okay, so you can see the variation in colors as pH changes. Okay, so finally, we talk about the applications of neutralization. So to summarize, antacid or maybe antacid, I'm not too sure about the pronunciation. Okay, these are medications to neutralize excess stomach acid. So it itself contains alkali. Okay, so sometimes when we eat too much, the stomach produces too much stomach acid. So you'll get conditions like heartburn, where you feel your esophagus heating up and in pain. So what you do is you eat this medication and it will neutralize the acid and relieve the pain. Okay, then in your toothpaste is weakly alkaline to neutralize acid present in mouth produced by bacteria. So this will prevent the acid from corroding your teeth. And lastly, soy. Soy that is too acidic or alkaline will not or rather the plants in soil that is too acidic or alkaline will not grow well. Okay, so usually soil in nature is typically more acidic because of acid rain. Okay, and what happen is for soil that is too acidic, we add calcium hydroxide usually. Okay, and this is the end of 11.2. Okay, so what we need to do now is to be able to write the word equations for these three reactions especially. Okay, on top of what was gone through in your activity book.